And then now we'll be having this session online. So thanks for your time. And then, of course, the welcome. And then for a few housekeeping rules, so we would like to request for your participation. So if you have questions to Anlor, you can. She will have a discussion session for some parts of the presentation, but also as a special format for the Benthic Habitat Part 3 today, we'll be having the one-on-one sessions later on. And later, I will show you how to book your slots for the time frame. So we will have the one-on-one consultation sessions also within this time frame. So in the Philippines, it's we have this 2 to 5 p.m. So later on, you can book the sessions from 3 p.m. And then you just have to go to your one-on-one sessions to have a discussion with Lore. So that's how we want to do this setup. And then again, we are recording, and we can request you to have your video mic and off if you have no other questions, or yeah, just to keep everything running smoothly. But feel free to message us on the chat as well, and especially if you have questions. But yeah, you can also have the consultation sessions later. And then as a routine, we would like to have the welcome from the European Union ambassador. So let's try to hear the few words from him again.
Good day to everyone. As the European Union ambassador to the Philippines, I am very honored to represent a European Union made of 27 European countries with a shared commitment to peace, prosperity, and sustainability, and democracy. The European Union is not just a political and economic union. It is much more. It is a global partner which values cooperation, inclusivity, human rights. Here in the Philippines, the European Union has been a reliable and consistent partner for over 6 decades. We support a very wide range of initiatives, from promoting peace, good governance, human rights, to enhancing common security in a complex geopolitical context, advancing digital innovation, trade, disaster risk reduction, green economy, and much more. This long-standing partnership reflects our deep commitment to working hand in hand with the Philippines in building a more sustainable, resilient, and inclusive future where no one is left behind. In the Philippines, a country especially prone to hazards and the consequences of climate change, this means supporting initiatives which create real opportunities for communities, foster innovation, build resilience in face of these global challenges. And in this context, the Philippines stands to benefit immensely from the integration of Earth observation technologies. This will strengthen the country's capacity to address climate and hazard-related vulnerabilities and will support biodiversity conservation. I am very proud, therefore, to introduce CopPhil. CopPhil is a unique flagship initiative of the European Union Global Gateway Strategy. It is managed by our team here at the European Union delegation, and it is implemented by the European Space Agency in partnership with the Philippine Space Agency and the Philippine Department of Science and Technology. CopPhil promotes the use of free and open satellite data from Copernicus, the EU space program's Earth observation component, through activities including the establishment of an IT infrastructure and Copernicus mirror site for accessing and processing Copernicus satellite data on biodiversity, on forest management, on agriculture, for example. This transfer of data is reinforced by the CopPhil training program, through which we are very excited to cooperate with institutions across the Philippines. These courses build a shared understanding of value and practical applications of Copernicus satellite data. Together, through CopPhil, we are advancing a partnership which empowers the Philippines to become a central hub for Earth observation in Southeast Asia and supporting its path towards a more sustainable and resilient future. I would like to sincerely thank all of you, the participants, as well as our partners and stakeholders who have made this training possible. Your dedication, your enthusiasm are the foundation of the CopPhil success, which is a very important joint initiative together with our Philippines counterparts. Let's remember that our progress relies on ongoing cooperation, shared learning, mutual support. The challenges in front of us are complex, this we are very aware, but it is united in purpose that we can build lasting solutions. Thank you very much.
So that's it from the European Union ambassador and a brief introduction again to CopPhil. And then just to continue why we're having this capacity building within the CopPhil. So we want to have this Copernicus mirror site in the Philippines. And with this framework, we have the EO pilot services. And from then on, we wanted to have the local capacity to be able to run and really use these services later on. So as a recap, from the very beginning, we had an introduction to CopPhil. We had the part one courses, more on the fundamentals of each services. And then we moved to part three, having a more practical uh, sense of how to run and process with the services and also the products available. And now we're on the applications part. And we've run through this whole training program series. So right now we're doing the Benthic habitat and we're on its final leg on the application side. And as a small teaser, so this week we're having all of the application courses. And then we're wrapping up everything on August 8th. So as you have already seen in your invitations, we're having this final event called the First Contact, and it will be held in Gateway Mall in Quezon City. So for a final wrap up and also to award all of you who had been attending our training programs some certificates and also like a small recognition on for all your participation all throughout this whole CopPhil series. So again, our materials can be found in the digital campus. uh, you need to have your account, and then every course will be in there, and all the data sets and also the recordings, you can find them there. And then also within this platform, you can generate your training certificate. So we have the certificate of attendance every time you access the course page, you enroll in the course and just answer a few questions. So one is on feedback, and the second one would be the quiz. After that, you will get an email notification that you already have your certificate. So just a reminder to everyone. So we've seen that not everybody was exporting their certificates, but yeah, it's possible throughout the platform. And then there's also a separate certificate that will implement later on, and you'll find more details later on. And then yeah, separate from the final event itself. But then again, welcome again to this Benthic Habitat Monitoring application training. So we have here Anne Lorbeck to have us a walkthrough for this one. But as a like the format that we will have now, we will have a discussion session with Andler for the first part, and for the second part, we will be having consultation session, so one on one. So Give me a second. So I invite everyone to visit this Excel sheet. So please kindly put your name and your email address just for a contact detail on the time slot that you wanted to have for the second part for the one-on-one. So how we will do it is that per session. So we we ask everyone to like like only join only on the time slot that they have booked, so that every participant who book a certain slot can have the whole one-on-one later on with Anlor. So basically we stay within this one Teams link. So like just to have this simplicity, also can share this session. So please write your name here. So for the 2 to 3 p.m. slot, it's more of like having the discussion, but please kindly write your uh, names here. So otherwise we will look into the session later, and we will be assigning each of you here in the sessions, and then we'll contact you to join on time. So that, and then so that and then I hand over to Laura for the main part of the Benthic habitat applications training. So from the last times we have learned the in the course fundamentals for benthic mapping, and then we had the practical session last time, and we had a walkthrough with her from accessing the satellite imagery and then forming the bathymetry maps. So now we'll be having again Anlor for the application course. So hi again, Anlor. So handing over to you.
Thank you, Carla. Let me share my screen. Up. Can you see my slides?
Yes.
Yes? Okay, it doesn't pop up on Teams. All right. So let's go. If you have any questions, I have the team meeting opened, so I can see if you raise your hand or if you ask a question on the chat. So don't hesitate to ask some question. We're really a small group today, so that will facilitate the exchange. So as Carla reminded us, we saw last time, so between training 1 and 2, we had different thematic. We will go through a recap at the second part of the agenda. First, we will just have a quick overview of the different product, the two main products of the Benthic service. Then we will see and have a little recap of what we saw during training 1 and 2. And then we will finish with the potential application. And then after a short break, we will have this session. So the session, and mainly for those who were there during training session 2, if you remember, you had different application, different possible exercise, or you were also very encouraged to run your own bathymetry map. So those dedicated sessions are really here to focus on your application, on your use case, and see if you have any troubles, or if you would like to, if there is anything you would like to exchange about it, if there is any problem. So these are all will all be assessed during the sessions. So a quick overview of the Benthic service product. So if you remember, we have two main products, the bathymetry map and the habitat map. So they're all at 10 meters because they're based on Sentinel-2 data. The main difference between the two, except that the fact that bathymetry is giving you the depth of the seabed, and the habitat map is to identify the different type of ecosystem. The bathymetry map is one image, one map, so you can have a bathymetry at a dedicated time, while the habitat map is a time series. So you need several images through time. Usually we need to capture different seasons to be able to build a map. So the bathymetry map is producing for every shallow water. It's giving you the seabed. And how it's work, just a quick recap. We are using the depths of penetration of light, trying to see to identify with the color of the pixel, the depth. So all color do not penetrate the water as deep as the others. Especially in coastal water, we have a depth of penetration that is reduced due to the different noise that we can have and the different sediment load in the water column. But ideally, we're matching a color with a depth through an empirical equation. And through this empirical equation, we have two coefficients, M0 and M1, that need to be estimated. So this is what we had seen with the calibration of the process, where we need to estimate M0 and M1, so different tests to have a good calibration that then can be applied to the whole image and allowing with a good calibration to map large area. I see. Yeah. Up. Sorry, I just need to see the teams were missing. Yeah. Then for the Benthic habitat maps, the idea was to see and trying to identify as many ecosystems in shallow waters as possible. The current, for example, NAMRIA maps are really focusing on coral, seagrass, and sand, while we know that it's a bit more complex than that. We have mixed environment, we have different type of coral reef, and we have different type of seagrass, algae. So this map, the purpose of this map was to try to identify all those different ecosystems and being able also to map them in coastal waters. So every time we have a Benthic habitat map that is linked with its confusion matrix. We're gonna regroup on confusion matrix a bit after. The Benthic habitat maps is relying on all band reflectances. So we know that the property of the ground is absorbing or reflecting lights. And depending on this absorption and reflection ratio, we can identify then what type of habitat we have on the ground. That works perfectly well for every features on land. For water, it's a bit more complex as we need to cross the water and atmosphere boundary. So in practice, how is it working? We have the Benthic habitat maps, and we're building some training samples that identify some different ecosystems. And then we have a machine learning algorithm that will match those training samples with empirical variables to then map the whole area, like for example, this habitat map for Apple Reef. Again, we always have the confusion matrix that is giving us for all different type of ecosystem, the different F-score and accuracy and the overall accuracy of the classification as well as the kappa index. So little reminder, the kappa index is the indicator of the performances of our training against a random, let's say, guessing game. So how those metrics are calculated, and I will mostly focus, for example, on this little 10 value that we have here in the classification. So how to read a confusion matrix. If I take the column here, for example, seagrass, we have 10 samples that should be coral reef, but are classified as seagrass. So then, ideally, we should focus on those 10 samples and trying to understand why the algorithm had some confusion. Now, a little recap on Benthic service. Any questions so far? I don't think so. Any question? Okay, so let's keep going then on the recap of the different sessions that we have for the Benthic service. So if you remember, during the first training session, we saw the different satellite data type. And for each, we really investigate the spatial resolution, feature recognition, and temporal resolution, and how these are connected with the satellite's property, orbit, and path. Those elements are really important when we do benthic or coastal monitoring to identify specific events. All events do not have the same spatial and temporal scale, so the selection of the proper image and the proper mission satellite is essential to be sure that we see the phenomenon that we want to monitor. More than that, the different sensors have different property, and during the training session 1, we identify and we saw that specifically for benthic habitat mapping or for bathymetry, the radar energy do not penetrate water. So we were constrained to the use of optical data. But even then, all wavelengths do not penetrate and reach the seabed. So we had to identify which sentinel-2 bands were actually useful, especially, for example, for the bathymetry mapping and for the depth retrieval. Then the training session 2, we're really focusing on practical exercise and manipulation. So after seeing all the Sentinel-2 data type and data structure, how to download them and where the information is stored, we had some QGIS manipulation to build a binary mask from NDVI. You probably will all recognize this nasty equation from QGIS that was problematic for some of you. And then we were talking about building an NDVI mask with keeping the NDVI value and moving on to the water mask. So I know that some of you have tried to complete this exercise later on. And this is also why we have this dedicated session afterwards, is to really focus on the task at hand, where you are on this exercise. For example, if there is anything that you would like to discuss, any issue that you found, if you would like to discuss some process, or if you try also other type of manipulation that you would like us to see together. Then after the break of the session 2, we really focus on the Send-to-Coral module and how to run your own bathymetry. So we first started with the calibration, why calibration dataset is important, and why a bad calibration can really impact your bathymetry map. So we saw together how to build from training datasets your calibration sets, and then how to apply it. So you had via Spider, because you had some demo code for Send-to-Coral, and also through the CopPhil service API. And so using the data provided for the exercise, you were able then to build your own calibration dataset and to run Send-to-Coral. The only thing that we didn't have the opportunity to see in training session 2 is the benthic habitat mapping. So the benthic habitat mapping is using as we discussed a bit earlier, is using a random forest process to map and to identify the different ecosystem in the seabed. So it's quite, it's a bit more, the calibration requires a bigger knowledge than the STV, because you need to build the samples based on your knowledge of the area. So your knowledge can be relying, for example, on Google Earth image, on ecological reports that state and map from field survey the ecosystem, but also on what you see on your satellite image. So you build your different training samples, you realize the classification map using, for example, the process that we are on GeoBuild platform, which is IOTA 2. And with the results, so you have the classification, you have the confusion matrix that we saw a bit earlier, and you also have a probability map. The probability map is giving you for each pixel the confidence of the algorithm that the pixel is well classified and the different probability for each class. from this probability map, we can build what we called an error map, a confidence map. So here we can see, so based on the probability for each pixel per class, I can identify the area where my algorithm is not sure. So if you remember, we had a good classification matrix. We were reaching 90% of overall accuracy, but my error map is, we have a lot of bad confidence, bad qualification score. So what does that mean? It means that with my good confusion matrix, my training data set is good for the area. Unfortunately, it doesn't cover everything, and the algorithm needs to guess for a lot of pixels, meaning that it has a bad confidence. So how to solve that? Let's focus on this area here when we have a bad confidence. So when we focus on this area, we can see that the classification map is mapping here some algae in the middle of deep water. When we look at the Sentinel-2 image, we can see that we're far from that. Here we have some deep water coral reef, and this dark blue is deep sand in the opposite of this very light blue, which is very shallow sand. So thanks to this error map, I can identify where the algorithm do not properly classify pixels. I can then build a new training dataset. So I decide to add the class deep sand. I'm adding also deep reef, but I'm removing algae because here he's mapping algae whether not, or seagrass. I call it algae, but it could be seagrass. So I'm removing completely to see if it helped the algorithm better. With this new training dataset, I have a new map. So reef sand, deep reef, deep water, and you can see we remove algae. So now I focus on this. I have my confusion matrix. So if you remember, we read in column. So in deep reef, we have one features that is classified as shallow sand, but should be deep reef, if you remember how to read. Overall accuracy, 99%, kappa, 99. So again, we have a very good confusion matrix that is saying that my training data set for the area is appropriate, and I have very, very few training samples that have been misclassified. So the information I'm getting from that is that my training data set is very precise. But again, let's have a look to the error map. Well, way better. We're really more in the good confidence score than the previous one. And if we focus on our area before, so we had this error that we wanted to correct, we can see that now it's the algorithm is more confident that the pixels are well classified. So of course, there's still some errors, and we will focus on those. So once we have a classification map, we calculate the confidence score map, identifying area where the algorithm is not sure, and that is giving us the information that we missed something. It's giving us the information that we need to adapt our training samples. Even if the one that we have are accurate, we forgot something. Something is happening where the algorithm needs to guess, and this map is leading us to identify where the guessing area are, and then how to build a new training data set. Any questions before I move on the potential applications? Okay, so I keep going. So now let's see some potential application for the Benthic service. So first, a potential application will be a time series of bathymetry maps. So we have so far one map, one date, one map. But as we know, there is a lot of different features. So if we have some glint, if we have some sediment load in the water column, we can it can affect the bathymetry map. So using a time series of bathymetry and merging them into one can allow us to have what we call a perfect image. So of course, I'm using perfect with a lot of cautions, but in allowing us to smooth out all those potential noise that we can see on image artifact. Big warning there with the temporal frequency. We have to be very careful between the conditional variation and the topographic change. So when you choose your time series of Benthic mapping to merge into one to smooth the different conditions, so water condition, climate condition, human variabilities, we have to choose a small temporal frequency to avoid smoothing topographic changes. When you have a change between two maps, is it because of the image variation, or is it because you had a change in your bathymetry? So if you don't want to smooth out the topographic change that we are trying actually to identify, you need to choose carefully your temporal frequency. So short range, so a short time period to do your temporal time series, allowing you to have the perfect image, while the long range is to smooth out bathy topographic changes. So if you have one image every month for 10 years, for example, you can see the change in the morphology of the seabed. So rocks that have been moved, sandbars that are moving and changing with the seasons, and even the disappearance, for example, of coral reef. Another application with the second product is the time series of benthic mapping. So the time series of habitat maps is used to do some habitat monitoring. So you can have some coral bleaching because healthy coral and dead coral will not have the same reflectance and will not be identified in the same class. But we have also done some tests, and we know that so you have coral bleaching that is irreversible. The coral is dead. But sometimes you have a pre-bleaching because of some bad condition. But if good conditions are resuming quickly, the coral can survive and be revealed. So those temporary change can be also identified with time series of benthic mapping. And you can see also the impact of different subsidence, landslides, and everything that is affecting the seabed. Then we can combine the different products. So if you combine, for example, the bathymetry map and the bathymetry, then you can first improve your bathymetry by having a calibration per type of seabed. So if you remember when we done the calibration on the training session 2, we were just looking at different points and selecting those points to do our calibration without considering the type of seabed. But we know that sand, rocks, and reef do not have the same colors. So if we try to identify color equal depth, of course, having some calibration per type of seabed will improve the bathymetry because we can focus on and calibrate on specific type of reflectances. And if you want to improve your bathymetry map, you can add a layer, a bathymetry layer, to characterize the different type of seabeds based on depth. So mixing the two products can either help you to improve SDB or improve benthic mapping, depending on where your interest is. But we can also combine the product, bathymetry and benthic mapping, with external data sets. So for example, we could add climates and weather data sets, for example, from the Copernicus data store. And that will give us some information on habitat condition. We could have some habitat type settings. So for example, coral reef needs a depth between 2 and 4 meters with a sea temperature between this range and some precipitation, no, not for coral reef, but with temperature, with pressures, with illumination, we can then specify the environmental setting for each type of seabed. And that allowing then on the long term to have some forecasting about habitat change. As we have with the IPCC some climate scenarios, so up to I think 100 years for the next century, we could also try to modelize. Okay, in 50 years we will have this condition. What will happen to my habitats? I change slowly the condition. I change the temperature. I change the sea level. I can then reproduce a bathymetry map and then see the impact on my habitat maps. So it will give us the information on the evolution of the different coastal environments through climate change and through times. We can also combine with anthropic data. So anthropic is everything that is coming from human activity. And so we can monitor the human impact. For example, the maritime traffic. If you have 10 years of habitat maps, you can then see the change of habitat that cross the major maritime routes, for example, and see how the boat have impacted the ecosystems. We can also follow the impact of pollutions, so you can identify on SAR data the different oil spills. And following then the pollution, you can see how it impacted with habitat maps time series. You can see how it impacted the different ecosystems. And a last possibility with the evolution from the past 10 years. In Philippines, we really have an evolution of mass tourism, and then see the impact of mass tourism on the ecosystem that are in the protected area. So that was for the overview of the potential application. Of course, there is several others. So don't hesitate if you have any question now, or if you would like to discuss potential application and see how this product can help you. And otherwise, well, I really strongly encourage you to book your dedicated session to discuss your specific use cases. If you don't have any further question, I give you back, Carla, the floor, and we can have a short break.